The last part of this chapter is the solubility product constant part. K, just like we've been doing before, is still the equilibrium constant with our products over reactants. The S and the P stand for the soluble product constant. So we're just looking at those products, the P, that are soluble in water. So if you look at the example down below, you'll see that solid calcium chloride dissociates into our calcium ion, that's aqueous, it's soluble, and our chloride ion, which is also aqueous, so it's soluble. When we set up these equilibrium expressions, we do it just like any other problem for equilibrium. It's always our products that are aqueous or gases over our reactants, which are aqueous or gases. If there's a solid or a liquid in the equation, don't use it. One other note about this is that if there's a coefficient like there is down here in front of chlorine, then you square that concentration when you set up the equilibrium expression. There are two types of problems that you can be given on the AP involving our solubility product constant. One is where you're given where you solve for the concentrations. You're given the Ksp value. So the first thing you need to do is set up the dissociation equation, which is given here. A lot of times you're just given the solid, and you need to know what ions it breaks up into. There's a worksheet in Moodle called Dissociation Practice with the answer key, along with another video that will help you with dissociation. Just a brief summary of that. If there is a subscript on an ion, then you form two of those in the product. So the concentration of your products here is going to be twice as big as the other ion. Again, here's our solubility product constant equation. It's just our aqueous products. We don't include the solid because solids aren't included in any equilibrium expression. We are given our Ksp value, so what we're going to plug into that is this number that's given to us. We're going to put it in for Ksp. If we had set up an ice table, we'd see that at equilibrium, our product concentration for calcium ion would be X, and we'd have 2X for the chloride ion. Here's an example of that ice equation that I was just talking about. Again, since calcium chloride's a solid, we're not interested in it. It's not included in our solubility product constant. With our products that are formed, initially they both start out with 0 as our concentration. Now the change will increase because we're producing our products, so that's why it's positive, and we look at the coefficient. So calcium, the calcium ion is plus X, and the chloride ion is plus 2X. So at equilibrium, oops, my E is kind of bad, we have our concentration for calcium as X and our concentration for the chloride ion as 2X. We plug these now in for our concentrations. Calcium becomes X and our chloride ion becomes 2X. So if we factor this in, we get 4X cubed. And then you solve for X. So you divide both sides by 4 and then use that special math function on your calculator to take the cube root. When you solve for X, you're solving for the calcium ion. Now to solve for the chloride ion, you need to multiply by 2. So you take that value and just multiply by 2. Now the last type of problem that you could be given for these solubility product constants equations are where you're given the concentration and you solve for Ksp. These are somewhat easier. Again, you still need to know how to set up the solubility product constant equation. You also need to understand that if they give you the concentration of one ion, you could figure out the concentration of the other ion. Now if they have the same coefficient, then it's the same concentration. If there's a different coefficient, then you need to multiply by that number. In this case, we'd multiply the concentration by 2 because of the 2 in front of chlorine. If there was a 3, we'd multiply it by 3. You plug in the values for concentration. Don't forget to square the chloride ion concentration, and that would give you your solubility product constant. Again, just to go over, Since this number is way less than 1, that means that we favor our reactants. Because this number is less than 1, not much of our solid that we start out with dissolves. The larger the Ksp, the more soluble your salt is. The more soluble your solid is that you start out with, meaning that the more ions you're going to form. So you can compare Ksp values and figure out which salts, which solids are most soluble.